Hey everyone, I got some bad news for you. Z-tests aren't that great. There are some serious problems with them. Let's talk about these problems together. Now, when we were discussing Z-tests for the first time, I actually mentioned that Z-tests are dumb. Why is that? Let's talk about that. Now, the main reason boils down to the issues with creating confidence intervals. I want you to notice something here. With every single confidence interval that we've discussed so far, I have given you the population standard deviation. Now, when you conduct a study, is someone just going to come down to you and say, hey, by the way, here's the population standard deviation? No, that's not going to happen. I'm not going to tell you what the population standard deviation is every time you conduct a test, because I don't know what the population standard deviation is typically. I mean, if you think about it, to calculate the population standard deviation, you have to study the entire population. And that's not easy. Now, I want you to think about this question. How do you calculate population standard deviation in the first place? Now, the first step in calculating the standard deviation is to calculate the average. So if we want to find the population standard deviation, we just find the population average. That's easy, right? Right? No, that's not easy at all, because we would have to sample the entire population and then find the average. And besides, this is the thing that we're trying to find. This is the whole reason we do confidence intervals and z-tests, because we're trying to figure out what that number is. If we found that number, there's no reason to do z-tests. There are no reasons to do the confidence interval. And there's no reason to compute the population standard deviation. So all that's kind of useless because we can't calculate the population standard deviation. So when you do an experiment, you can only find the standard deviation of your sample, not the population. I mean, think about this. The purpose of your experiment is to make a claim on what the population average is. Why would we calculate the population standard deviation when step one is the final step? We would never need to do the other 4 steps because step 1 would be, we're done with our experiment. The purpose of our experiment has been fulfilled. Now, there is a solution to this. We're not going to calculate the population standard deviation. That's just typically not possible. But what we can do is we can compute the standard deviation of our sample and just say that, well, that's pretty close. Because the sample is representative of the population, right? So the standard deviation of that sample should be roughly the standard deviation of the population. So you can just calculate the sample standard deviation and use that number instead of the population standard deviation because they're really close. Now that's actually a problem because the standard deviation that you calculate from your sample is probably different than the population standard deviation. Now I want you to think about this. Why is that a problem, that they're not the same? What could happen? Now, I want you to consider this hypothetical that would be really inconvenient. What if your sample had a significantly low sample standard deviation compared to the population? So you don't have your population standard deviation, so you calculate the sample standard deviation, but it just happens to be conveniently lower. What would happen in that scenario? Well, if your sample standard deviation is too small, then your margin of error in your confidence interval is actually going to be smaller. And you can look at the math and verify that. Well, so to fix that problem, because your sample standard deviation might be small, z-tests are just unreliable. Also, keep in mind that z-tests assume that you're working with a bell curve. But sample distributions are only bell curves when your samples are really relatively large. That's what the central limit theorem says. But if your samples are small, then z-tests are also unreliable. Now, there is a solution to these problems. It's called the t-test. And we're going to be talking about that in the upcoming lectures. So I'll see you guys there. You just watched a video from More Learning. We provide free math videos and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. and put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.